So thanks a lot for giving the opportunity to be here as speaker at the conference here. And a few words before I start about the company. Probably as you see, we are in jet engine business. We are not an OEM. We are a so-called partner. And we develop and produce subsystems for jet engines. Maybe you fly on a A200 series, and it's exclusive where we're involved in. And the company is about 10,000 people plus. And from their side, we have a maintenance, repair, overhaul facility. We are providing maintenance and repair overall services for whole jet engines, or also for engines we are not involved in the OEM business. And that's more or less all about the company. So that I skip. Okay. So I'm from my end user. It's an end user story what I'm talking about. And at the time we started with a U-shaped line. That was in about 2009, 2010. We got the opportunity to be part of a new engine project. And that type, we had equipment called U-shaped line. It was typical lean environment. And in that area, we saw that we do not have sufficient space, floor space, in order to do with that topic here. And the cost structure was not sufficient in order to do it, so we have to do something new. And my presentation is about something new we did. And at the time, we switched to a so-called flexible production line. That was before Industry 4.0 was born. But therefore, I set up a lot of elements from 4.0 and 5.0. And we had two things to master. One, from my point of view, is always this so-called strategy. That's for the rational stuff we have to do, the plans and everything. We call it hard stuff. And you have something to do that we call transformation. That's the soft stuff. How do you change your mindset and enable the company in such a way and the organization unit that is capable of doing the journey from the old to the new. So now talked to one of from the audience before I start. A new type of production system, from my point of view, is not the principles anymore. Maybe famous production system is Toyota production system. In our case, there's something new that's from my side. You have to, of course, still focus on efficiency. On lean is a lot of topic focusing on efficiency. That's fine and it's still needed. But it's, as a single issue, it's not sufficient because we are not in a stable environment anymore, even a dynamic environment. So you need some kind of adaptability, and it has to be built into the system. If you don't build it into the system, you're maybe not flexible enough in a turbulent, or in the morning, as they call it, a perma-crisis environment. You need that flexibility and adaptability. But if you build in that adaptability, you have to build in a second topic in the same type. It's the resilience, the robustness into the model. If you don't do it, you run into a problem. It's not stable enough. And the sustainability is more or less, you have to do it, otherwise you have a problem. Now we go to aerospace manufacturing, especially in the area was during that time. It's not possible to go to fully automated operation because there are a lot of barriers, physical barriers. A lot of machines are not capable of doing jobs a human being can do. And due to physical things, and otherwise you need the intelligence, and the intelligence is not available, required for doing some jobs. Therefore, it's always a combination human and machines, and therefore we have to combine both strengths. So what you see here is an older photo from the production line. At the time, we are now going to the next evolution of that line. That's the Gen 2, as we call it, and the Gen 3 is on the way. But today I'm talking about the Gen 2 because I want to let you give some experience back what we have got from the last 10 years plus based on Industry 4.0 and Industry 4.5 experience. So that line is located in Munich. It's a rail line, it's producing. We currently run 5 parts from as needed from the market on that line. Out of 9, the rest is already on the Gen 2, on the next evolution of the system. And the time I got involved, we defined, okay, we want to have a 24/7 capability, that machines are currently running 24/7 again. During COVID, of course not. Then they say we need the adaptability. And they said, okay, adaptive means in our case that it's possible to have a rough alignment and to do the precise alignment of the part within the machine in order to get out the influence of the personnel. Furthermore, to have the capability to run it based on feedback from the machine, from the CMM, bring it in and do it automatically. Of course, the flexible stuff in order, the volume flexibility and time flexibility. Setup is done parallel to machining. And the agile area, that line was built for 2 engine families, for smaller parts. And we got an opportunity to enter a large engine project. At the time that the machines are too small. But we were able, due to the agility and the flexibility, adaptive stuff, to bring in a part that is 40% larger in that line, and without some doing, due to the flexible architecture, and give us the opportunity to be ready for a new thing at once. So, and the next thing at that time, it was brand new, bring data to value, to business value. So, if you go to a flexible line like this one, so there are a lot of topics you have to cope with. The first thing is you have a human dimension, and there was a lot of talk in the morning. And it's why have I put the interface so large? I show you later. The interface is for a lot of people something add-on, but it's in our case it's a huge value driver. And if you do it the right way, and it's a huge impact. And the next one is the machine dimension. The machine dimension is what the system built, and it's a key enabler dimension, and that's often forgotten. If you have chosen the wrong architecture, you want a flexibility, adaptability, you want a resilience, you have to invest in an architecture with that capability. If you have a monolithic, hardcore coded stuff, it's some way possible, but it's very hard. We did it in a different way in that area. So now we have already talked about the strategy. Now at the time in 2008, 2009, 2010, a lot of people had the focus on the physical assets and then also on the machine focus. And the transformation was required that you see the physical and the virtual assets. Virtual assets means the software and the data. And an important topic here is that you think and act like a tech company. We implemented in that area a type of platform. We did improvements via software. And we did the improvement via software. Due to the architecture, it was possible, and is still possible, to run different software versions on a cell, because modular, autonomous, and we can test software and run it, how good it is, and what it brings on a single machine in comparison with the others. And we do not have to test it up front and make a big bang approach. So that was totally new at that time for a lot of people in the company. So now it comes to some topic. Maybe I go back again to the transformation. I want to say two topics again to the transformation. From my point of view, so in my experience, there's 3 top things. One is the technology. It's not the hardest stuff, but it's challenging. The second thing is, if you go to the transformation, and you have to do upfront investment, and you have to invest in a platform, or would like to invest in a platform. It's much harder to justify than to do something singular. But you need the ecosystem, the platform, in order to go to Industry 4.0, 5.0. And that to make to people clear. Now it's easier, but at that time was very challenging. And the second thing, as I already mentioned, is that people have a lot of experience with the best practice and so on. To see that that best practice is past practice, because you have a new environment, and you go to something new. It's not valid anymore. To bring that topic into context and say, okay, if you're in the old environment, my best practice is valid, not in the new one. And you have to build something new. And that's the quote I found in order to strengthen that. Now, let's go to the interface, as I mentioned before. The interface, people and my system has to communicate each other. And the better they understand each other, the better the performance of the line is, and the better the productivity is. If you want to have big productivity, so you have to invest something. Now, get a step deeper, and now from the perspective from the human side. What are the human perspective and requirements towards the interface with the system? So I said, okay, I want to act in an intuitive way. If you make that possible, you do not need any training. The second thing is, if you do it that and do not need any training, you get a much higher flexibility, adaptability, because you can bring in people from outside or from other areas without any training. You do not have any lead time, minimum lead time. It's a huge enabler. And the other thing, if you have an intuitive interface, it creates acceptance, because people say, okay, I know what's going on. It has to be that way. It's here. And resilience, because if you act intuitively in the correct way, it's resilient and robust. And the other thing is, it brings efficiency, because you do not have any training. It is fast on adaptability. Now, if you go over what is the machine, how does the wishes towards the humans, given this stuff so they can understand it. And understanding it means giving this stuff in a machine-readable form. And at the time, we implemented RFID and QR code, or 2D matrix, as you call it, because it's machine-readable, it's efficient. We have a whitelisting. Everything the machine knows says, no, I don't accept it. And still, we have the adaptability via selection and the keyboard. But that area is done in such a way, it's only for special, for outliers, for things, not the mainstream. The mainstream always is on the QR code, 2D matrix, RFID. Now something at the time, now it should be quite common. If you change from an industry 3.0 to a 4.0, 5.0, you have two value streams. The one value stream, of course, is the machining. Visual stuff is quite clear. The second one is the virtual value stream. And the SAL, or the machining, we do not call it a machine anymore, because it's a whole ecosystem. And the SAL produces one part at a certain area. It's aligned to both things. The architecture below, in order to do that, we call production architecture, and the whole system we call production system. No, it's a bit different approach. Now, that's the picture from the start. The physical value chain, value engine is quite clear. But now you have a second one. That's the analytics stuff, and you machine data to value. And you get data from the process, get data from external, bring it into the analytics and feed it back to the machine. Optimization, quite clear. What a lot of people forget is the risk reduction. You cannot ask any people anymore if you have a problem. You have to ask the machine. The machine talks data, and you have to be able to understand data. And then make it understandable and make it clear, you need analytics. Yesterday we had a problem and got a call from from the shop floor. I said, okay, we have that effect. What do you think is your judge? We were able to fix it within minutes because it was a fixture problem. Based on data, it was clear how to do it. Without that, it takes you at least several days or even more, or you never find it. You had fair cases without the data, you wouldn't have found it. And of course, the second one is database product. We feed back the performance may, for instance, from some tools back to the supplier and said, okay, well, that's the performance. Why has it happened that way and why run it that way? Go. Now, the big next change in mindset, see data as a product. If you see data as a product, it has a value, it's a reputation, it gets the infrastructure as a product. If you don't do it, you run into a problem. And the first dimension is in talked area. In aerospace, there's a lot of intellectual property. You can do it both ways. If you're clever, maybe you can protect the intellectual property. If you're first a leader in that area, the master data management is required in order to have all the stuff formatted and so on, as I mentioned before, in order to make data a product. The unique identity is required. If it's not there, you cannot do any analytics because you cannot address the right things. And the trustworthiness of data is, of course, a must. Without that topic, you cannot distinguish, is it a fake news or is it something real topic? Now, the outer idea already mentioned, the unique idea I mentioned now also, that both things connect the physical and the virtual world and the data. Why is the data so important? If you have a time perspective, and depending on the time stamp you see, the physical and the virtual product has different conditions. Without that unique ID, it's not possible to see what's going on and to address the right data. For instance, when we have a rework of a part, you have to make clear what you want to see. First time right, or as delivered. If you do not have the auto ID and the unique identity, it's impossible to distinguish. So, now, there are a lot of different perspectives on data. The data comes out from the machine, as I mentioned before. And a lot of topics are important. Yesterday, as I mentioned before, problem was a fixture problem. We were able to address it. And of course, the part perspective is very important. It's the life cycle, what has been done on the part. If you want to see it, what has happened. And the machine focus is very important. And now I go a bit deeper to time. The time, of course, topics, operations happens in the present. And if something happens in the past, have a problem. Normally, if you see it later, then you have to be able to see what has been done in that area. And that past data is also of importance to train or to enable the stuff in the future, because you need high quality data, and high quality data is produced in that area, past data, and you use that to train the models in order to predict and prescribe something. Now, a multi-layer, multi-dimensional platform, why is it so important? Because you have different perspectives and requirements. One requirement is if you're very near on the process, you need fast performance, fast data. You have low compute power. If you want to have maybe a fleet analysis, you need much more compute power. You give up, but you can do it later. It has not to be in real time. So now, what the line is doing, it's driven by the customer requirements. We implemented a flexible toolkit. A flexible toolkit means not something monolithic, it's a modular stuff. And then we free the data from data silos. It's available. Otherwise, you cannot do the analytics, because if it's not free, the part is also free, the physical one. therefore has the data for the virtual one, so in order to do it. So the core message is here. A holistic approach is needed. If you don't do it, you probably do not come to the sufficient success. Now, 2 quotes in order to stop. The first thing, I think, one has to decide, do you want to be a leader or follower? If you want to be a leader, you go more risk, reap more benefits. And you probably do not have any best practice. You cannot rely on something. You go to white turf. We did it, and that time, a dramatic increase in performance, but reduction in cycle times, decreasing cost, and so on. And the next quote I would like to stress here: never let a good crisis go to waste. We had an opportunity, we used that opportunity, we had a dramatic impact. The important topic is the mindset. If the mindset is, let's see the opportunity instead of the crisis, you can do something. The involved people acted like a startup within a big company, and some called about the dream team, and we had a huge success. And that's from my side.